Hello everyone, in today's video we're going to be having a look at electrophilic addition mechanisms, and the first one we're going to have a look at today is the electrophilic addition of hydrogen gas. Now we need to know two things. We need to know the mechanism and the reaction conditions. Both of those you can be asked about in the exam. We will start with the mechanism. So let's draw ourselves out an alkene, because electrophilic addition is all about the addition of a small molecule across an unsaturated functional group's double bond. And the alkene has a carbon-carbon double bond where there is a high concentration of electrons and negative charge. Now, that high concentration of electrons and negative charge is going to induce a dipole in the hydrogen atom. It's going to be repelling those electrons in this bond here away. And what happens is two electrons come from the carbon-carbon double bond to halfway between the carbon-carbon double bond and the hydrogen atom. And this forces the two electrons in the bond to jump back onto the delta negative hydrogen. And that's our first step. So in our first step, we have two lone pairs and a dipole. Now that step is the rate defining step. It is the slowest step. And what we've formed essentially is what's called a carbocation. It's a molecule that has a positive carbon atom on it. So there's our positive carbon atom. Because it is electron deficient, this carbon atom is missing an electron. But what have we also got? We've now got a hydrogen ion with a lone pair of electrons and negative charge. Now, we all know negative and positive attract. This is going to be ionic attraction. And here we go. This lone pair is going to establish a covalent bond, again, equidistant between carbon and hydrogen, forming our fully saturated product, which is an alkane. So, in summary, our mechanism, the slow step is the attack of the electrophile. The electrophile is the delta positive hydrogen. So if you're ever asked to label up the electrophile in the exam, the electrophile is the delta positive hydrogen, not hydrogen gas. You won't get the marks for saying hydrogen gas. You have to say the delta positive hydrogen. So the first step is electrophilic attack of delta positive hydrogen. Two electrons come out of the bond to form a covalent bond between the carbon and the hydrogen. This pushes the two electrons between the hydrogen-hydrogen bond onto this delta negative hydrogen. This forms our carbocation and a hydrogen ion. The lone pair from the hydrogen ion sets up a covalent bond with the carbocation. This is a fast step, forming overall our fully saturated alkane. So, quick checklist: 3 curly arrows, 2 partial charges, a positive carbocation, a negative ion, and a lone pair. And if you've got all those, chances are you've got it right. Now we need to have a look at the reaction conditions. There are 2 possible ways we could go with this. If you've got lots of money and you're really rich, you could go for a platinum catalyst and room temperature. If you haven't got that much money, then you might be thinking of a nickel catalyst, but at 150 degrees C and 5 atmospheres. And that's it. That's the electrophilic addition of hydrogen across an unsaturated alkene functional group. Now be sure to check out our other videos in this series about the electrophilic addition of bromine, hydrogen bromide and water. And if you found this helpful, don't forget to give us a share and help someone else out. Thank you.